we're going to sketch this function f of x is equal to x squared over x, because we want to figure out what it looks like. So in order to sketch the function, we're going to sketch it on say this axis here. So we've got let's call this the x-axis, and here's the f of x axis. So we're going to fill in values of x and figure out what f of x is, and then we're going to plot the points. So let's say when x is equal to 1, f of x will equal x squared over x, so it'll equal 1 squared over 1. Just fill in 1 into this because x is equal to 1, and 1 squared is 1, 1 divided by 1 is 1. So that means the point 1, 1, x equals 1, f of x equals 1. The point 1, 1 is on the graph, so the point 1, 1 would be, here's 1, and here's 1 on the f of x axis, so there's the point 1, 1. Okay, let's fill in another number. So say x is equal to 2. So that means f of x is equal to 2 squared over 2. 2 squared over 2, which would be 2 squared is 4. 4 divided by 2 is 2. So that means the point 2, 2 is on the graph. So 2, 2 is on the graph. So I'm going to plot that point. 2 on the x-axis, 2 on the f of x-axis. So there's 2. So that would be just here. Okay, let's plot another point. So say x is equal to 3. So then f of x would be 3 squared over 3. So 3 squared is 9. 9 divided by 3 gives us 3. So the point 3, 3 is on the graph. You can see the numbers that are going to be on the graph all the time here. So we got the x value 3, f of x value is 3. So 3, 3 is on the graph. So the function is going to be up just here. And let's fill in a few negative numbers. So say let's fill in when x is equal to -1. So -1 would be out here. So here's -1. So when x is -1, f of x would be -1 squared all over -1. So -1 squared is 1. 1 divided by -1 gives us -1. So you have -1 is on the graph. So -1 would be, here's -1, would be just down here. You can see there the points are forming a straight line. Let's fill in another negative value. So let's say -2, and here's -2 down here. So when x is equal to -2, then f of x would equal -2 squared over -2. -2 squared is 4. 4 divided by -2 gives us -2. So the point -2 is on the graph. So -2, -2. Okay, so the function, this is what the function looks like if I was to plot it. It's a straight line. But there's one very important point. Let's say x is equal to 0. So x is equal to 0 right here. So when x is equal to 0, let's have a look at the function. So f of x would equal 0 squared divided by 0, which is equal to what? Well, if we look at that, the top bit is fine. 0 squared is 0. But now we've got 0 divided by 0. And 0 divided by 0 makes no sense. It's undefined. Undefined. So that means that x can never be 0, because when I fill in 0 into the function f of x, I end up dividing by 0. And we can't divide by 0. It's undefined in maths. So x can never be 0. So at this point where x is equal to 0, I'm not going to put a point there. I'm just going to draw a circle around it, because the function x can never be 0 in this function. So the question said, what does the function f of x is equal to x squared over x look like? Well, it looks like this. It's pretty much a straight line, except when it gets to 0, 0, there's a break. Okay, we'll just move that point up there. So when it gets to 0, 0, there's a break. The function doesn't pass through the point 0, 0, because the x value can never be 0. So when we have a function that looks like this, we say that the function f of x, this function, is equal to x squared divided by x, is not continuous. It's not a continuous function. A continuous function is one that I can draw without lifting my pen off the page. So say if I was to draw this function, f of x is equal to x squared over x, I draw it. Once I get to this point, I have to lift my pen off of the page, and I have to start again up here because we never pass through the point 0, 0 because the x value can never be 0 on this function. So let's have a look at what a continuous function would look like. So say if I was to plot a graph of the function f of x is equal to, let's say, x squared. So this is one that we've seen a lot. It's pretty easy to plot. So let's say I'm going to minus 1, minus 2, minus 3. So you have 1, 2, 3. The x value, or the f of x values, this is the x-axis. We have the f of x-axis up here. So we go 1, 2, 3. Well, actually, I'm going to go up in 2. So we'll say 2, 4, 6, 8, 10. And up here we've got, put it at this side, 12. Okay, so f of x is equal to x squared. So let's say when x is equal to minus 1, f of x would be minus 1 squared, which is 1. So the point minus 1, 1 is on the graph. So minus 1, 1 would be just here. X is equal to 0, let's say this time. So we have f of x is equal to 0 squared. Just fill in 0 here. 0 squared is 0. So the point 0, 0 is on the graph this time. So 0, 0 is on the graph. So you have it there. X is equal to, let's say, minus 2. Just fill in any values of x. We have f of x is equal to minus 2 squared, which is 4, which means the point minus 2, 4 is on the graph. So minus 2, 4 is up here. So this point is on the graph. X is equal to, let's say we'll do a few positive numbers. So x is equal to 1. F of x would equal 1 squared, which is 1. So the point 1, 1 is on the graph. So the point 1, 1 is here. X is equal to 2. F of x would be 2 squared, which is 4. So that means that point 2, 4 is on the graph. 2, 4 is on the graph. So 2, 4, which would be here. And we just fill in one more. So let's say x is equal to 3. F of x would equal 3 squared, which is 9. So the point 3, 9 is on the graph. So you're out to 3 and up to 9, which is just here. So let's draw the function there. So we come down. It's coming from here. Comes down, it passes through 0, 0. If you look at this function, I can't actually draw it without lifting my pen. I know I did lift my pen off the page, but I could draw it without lifting my pen off the page. I actually got a nice curve there. The function, I could fill in more values of x. So say x is equal to 4, or x is equal to 3.5, or 3.1, or 3.2, or minus 1.5, or any values of x I could fill in. And when I fill in values of x, I will always get a corresponding value of y. And this function will continue. It'll continue up this way. And it'll continue up this way. There'll never be a break in the function. It'll always continue. So we say that the function f of x is equal to x squared is a continuous function. So this is a continuous function. So if you want to try another one, let's say if you were to plot the function, let's say g of x is equal to, let's say, x plus 1. If you were to plot that function, this function will turn out to be a continuous function. So you can try this yourself. It'd be a good idea to plot it. Fill in values of x into this function, get corresponding values of g of x, plot it on a graph, and it will turn out to be a continuous function. There won't be a break. So the only reason that this function turned out to be not continuous is because there is a break. X can never be 0 in this function because we can't divide by 0. So when we fill in a value of x as being 0, we get an undefined answer. We don't get a corresponding f of x value, so that's why we have a break. So this is not a continuous function. And this idea of continuous functions leads us to a really nice and important theorem in maths, and a theorem that makes things, it makes working out limits a lot easier. So if you remember in the first video, I think, on this section, I was showing you how to work out a limit by drawing a table. Well, this theorem here gives us a much easier way to work out a limit. So I think, if I remember correctly, we had to work out in the first video, we were trying to work out the limit as x approaches 3 of 2x minus 1. So this is the function 2x minus 1. So let's have a look at what the theorem says and how we can use that to work out this limit. So the theorem says, if a function f of x, which is this is f of x in this case is equal to 2x minus 1. So f of x is equal to 2x minus 1. So if a function f of x is continuous at a particular input value, let's say x is equal to c, so if it's continuous here at x is equal to c, then the limit as x approaches c of f of x will equal f of c. So what does that mean? Well, it means that if I take this function 2x minus 1, and if this is a continuous function, which it is a continuous function. If you want to draw it quickly, we can draw it. So let's say we were to draw, okay, so I'm just going to draw very quickly. So when x is equal to 1, we get 2 times 1 minus 1, which is, so x is 1 here, 2 by 1 minus 1 is 1 also. So let's say there. When x is equal to 2, we get 2 by 2 minus 1. There's x is 2, there's x is 1. 2 by 2 minus 1 is 3. So there's 1, 2, 3. So there's the point up there. So we get 3, 1, 2. Let's fill in a negative value. So we have, say, minus 1. 2 by minus 1, when x is equal to minus 1, 2 by minus 1 would give us, 2 by minus 1 is what? 2 by minus 1 is minus 2, minus 1 is minus 3. So we have minus 3 down here, so the point minus 1, 3 is on it. So I can fill in any values and I will get a corresponding value of x. So let's say I fill in x is equal to 3. So when x is 3, 2 by 3 minus 1 would be 6 minus 1, which is 5. So 3, we have 4, 5 is up here. So here we have it here. So this function is going to look like this. It's going to be a straight line. It's going to come down here like this. So look at what this theorem says. It says if a function f of x, so this is the function, is continuous at a particular input value, x is equal to c, then the limit as x approaches c of f of x will equal f of c. So we have to work out this limit here. So let's have a look at the graph. Is the graph of 2x minus 1 continuous at x equals 3? Well, when x is 3, the function is up here. And it is continuous there. You can see this line continues forever, goes up here. So there's no point in this graph where it's not continuous actually. So because it is continuous, in order to work out this limit, using this theorem here, all I have to do is fill in the value of 3 into this. So I go 2 by 3 minus 1, and I guess 2 by 3 is 6, 6 minus 1 is 5. So the limit of 2x minus 1 as x approaches 3 is equal to 5. If I want to work out, let's say, the limit of x squared, we know that x squared is a continuous function at all values for x. It's always continuous. So the limit of x squared as, let's say, x approaches 4, going by this theorem, an easy way to work out this, because when x is 4 in this function is continuous. So all I have to do is to fill in 4 into the function. So I fill in 4 squared, which is 16. So the limit as x approaches 4 of x squared is equal to 16. Let's have a look at one more. So let's work out the limit as x approaches, let's say, 5 of, or it could be a minus number, so let's fill in a minus number. So x approaches, let's say, minus 5. So the limit as x approaches minus 5, and we'll just do x squared again. We know that x squared is a continuous function. So the limit as x approaches minus 5 of x squared is equal to just minus 5 squared, which is 25. So this theorem here and the idea of a continuous function gives us a very, very easy way to work out limits.